For section 4.3, we're going to talk about something called the factor and remainder theory. But before we do this, we're going to brush up on some skills you learned in intermediate algebra. And the first one of those is long division. Now, I've written the steps on how to divide polynomials using long division. And you'll note this only works when we're dividing by a polynomial that only has two terms, and the x is to the first degree. It's a polynomial to the first degree. But we can we have certain things that we have to have about the polynomial we're dividing into. And I want you to note these over here. They're in number 1. We have to write it in long division form, arranging the terms in descending orders. Each of these polynomials has to be written in descending order. And if there is a missing term, note the second one, you have to fill it in with 0x to the whatever power you're missing. So let's check out our top term here. It's x cubed minus 4x squared plus 2x minus 3. It goes from x cubed to x squared to x to the constant term, so it's fine. So is our divisor. It is just x to the power of 1 plus the constant term, so everything's okay. We're going to write it as a division problem, and the way we do that is we simply put the division house out there. You've done long division, but it's probably been a long time. But we divide by x plus 2, and we're dividing into x cubed minus 4x squared plus 2x minus 3. All of that's under the division house. Now, we have two terms, and we have to divide into those first two terms. So our first response, our first answer here is going to go over the second term. And I look at it and I say x divided into x cubed. In other words, I could say x cubed divided by x, what would that give me? Or I could say something times x would give me x cubed. And I think, okay, well, that would be x squared. X, and then I multiply. I say x squared times 2, and I put it under the same term that it's written on top of. So x squared times 2 is a positive 2x squared. And x squared times x is a positive x cubed. Now, I'm going to subtract. Since I'm going to subtract those two terms from the two above it, I have to change the signs. This becomes negative, and this becomes negative. So when I subtract x cubed minus x cubed, of course, I have 0. That was the goal, was to get rid of that first term. But negative 4x squared minus 2x squared is going to give me a negative 6x squared. And I'll bring down the next term, and I'll divide again. Negative 6x squared, what if I divide that by x, what do I get? Well, I get a negative 6x. And you can think about it this way. Negative 6x times x gives me negative 6x squared. So I'll multiply it times both of these terms. Negative 6x times 2 is going to give me a negative 12x. Negative 6x times x is going to give me my negative 6x squared. And I'm going to subtract those two terms, so I'm going to change their signs. Well, they're both negative, so I'll switch them to positive, subtracting a negative, adding a positive. That eliminates these first two, and I have 2x plus 12x. I'm going to end up with a positive 14x. You don't have to write that plus, but I just did it. Bring down the last term, and I want to divide. I'm going to say, what if I said 14x divided by x, I would have a positive 14. Thinking about it the other way, 14 times x would give me 14x. So I multiply 14 times 2, and that gives me a positive 28, doesn't it? 14 times x is 14x. Now I have to switch these signs again so that I can subtract. This becomes negative. This one becomes negative. And the first two are eliminated. Negative 3 minus 28 gives me a negative 31. So I do have a remainder. How do I write that remainder? Well, I say plus negative 31 over the divisor, which is x plus 2. And that's our long division of polynomials. I've got a couple more for us to practice with. This one, let's check to see if it's written in descending order. I've got x to the 4th, x cubed, and it's not written right at all, is it? So let's rearrange this. I'm going to say 2x to the 4th plus 4 x cubed. I need an x squared term, so I'll add in plus 0x squared. And then I have the x term plus 26x, and I have the constant term minus 8. And all of that is divided by this trinomial, x squared minus x plus 4. All three terms are present, and that one works, so I don't have to rewrite that one. Let's write it under my divisor house here. And I'm going to say I want to take, so I'm trying to figure out how much room I need to leave. I want to take 2x to the fourth plus 4x cubed plus 0x squared plus 26x minus 8, and I'm going to say I'm going to divide it by this trinomial, right? And I'm going to divide by x squared minus x plus 4. Well, I'm dividing by three terms, so my first answer has to go over the third term. I'm just going to draw a line so I don't mess it up. I'll be putting it over the x squared term. I have to look at the first term in my divisor and the first term in the number I'm dividing into and say, what if I took 2x to the fourth and divided it by x squared, I would have 2x squared. That's what I'm going to start with. And then I'll multiply 2x squared times 4. I'll write it underneath. It would give me 8x squared. And it would be positive. It's a good idea to keep these signs straight. And 2x squared times negative x is going to give me a negative 2x cubed. And 2x squared times x squared is going to give me a positive 2x to the fourth. Now, I need to subtract these three, so I'm going to flip all the signs. The first are eliminated, of course, and it doesn't really matter which ones you add or subtract next, but I'll say, okay, this is a positive 6x cubed, and this is a negative 8x squared, and then I'll bring down the next term, which is 26x. So I want to take this 6x cubed and divide it by x squared. It would be 6x would be what I need. So my next term is going to be a positive 6x. And I'll multiply. 6x times 4, of course, gives me a positive 24x. 6x times negative x is going to give me a negative 6x squared. And 6x times x squared is going to give me a positive 6x cubed. I'll switch all these signs so that I can subtract these. The first are eliminated. Negative 8x squared, positive 6 is going to give me a negative 2x squared. Negative 26x minus 24x is going to give me a positive 2x. And I'm just going to see if I could do this one more time, but I really don't have another term. Oh, yeah, I have one more term, 8. So I've got three terms. I'm going to divide one more time. I'm saying negative 2x squared divided by x squared. Well, negative 2 should be what I need. Negative 2 times 4 gives me a negative 8. Negative 2 times negative x is going to give me that positive 2x, isn't it? And negative 2 times x squared is going to give me a negative 2x squared. Now, you note these three terms are exactly the same. So when I subtract the exact same thing, I'm going to get 0, but flip the signs so you'll see it happen. And all of them cancel, and I end up with a 0 remainder. A 0 remainder is one thing I'm going to be looking for when I do this factor and remainder theorem. So this one, the answer is 2x squared plus 6x minus 2, no remainder to be listed. Let's do one more this way, and then we'll switch over and practice some synthetic division problems. This one is all messed up. We're going to have to rearrange it. We'll start with the highest exponent, so we have x to the fourth. That's the degree of our polynomial. It's a fourth degree, and I don't have an x cubed term, so I'm going to have to write one in. I do have the x squared, and I do have an x term, and I do have a constant term. Now, it's going to be divided by, I'm going to go ahead and write this out because I'm missing a term in my binomial. I'm missing the x term, so I'm going to have to add that one in as well. I'll say plus 0x minus 5 because I have to have, all the terms have to be present in both the dividend and the divisor, okay? Now I'm going to write this under my division house as x to the fourth plus 0x cubed plus 3x squared minus 10x plus 16. And I'll say all of that is divided by my trinomial now, x squared plus 0x minus 5. Now, I'm going to be dividing 3 terms, so I'll be putting my first response, my first part of the answer will go over the third term. I'll say x to the fourth. What x to the fourth divided by x squared is just plain old x squared. So I'm going to start with that. X squared times negative 5, negative 5x squared. X squared times, well, anything times 0. So I can say this is a positive 0 x cubed, right? And then I'll say x squared times x squared is going to give me x to the fourth. And let's switch all these signs so that we can subtract. Now these are eliminated. This is really eliminated because 0 minus 0 really isn't there at all anymore. That term went away. And now all I've got left is 8x squared. So when I bring down this next term, it's not enough for me to divide all 3 terms into. So I'm going to have to put a plus 0x here. This is the x term, so this is going to have to be this factor, or this part of my quotient would be an x. So I'll just say 0x, there's nothing there. And then I'm going to bring down the last term, the 16. 8x squared divided by x squared, positive 8. I say 8 times negative 5 is going to give me is negative 40. And 0 times 8, I'll just write it in here. It's going to be a positive 0. That's my x term, so I'll write it as that. And 8 times x squared is 8x squared. Let's change all these signs so that we can subtract them. And what do we have? Well, we have a positive 56. And we have negative 10x minus 0x, right? So when I do that, I still have negative 10x. So my remainder is right here. It's a binomial as well. It's going to be plus 10x plus 56 divided by, and I don't have to write in the plus 0x anymore. I can say x squared minus 5 for that remainder. Okay, that's just a little bit of practice that we need in long division, and hopefully you remember that from intermediate algebra. Let's go on now to the next page where we're going to work on synthetic. Now, for synthetic division, we're a little restricted. If you have a page, by the way, that this word is says division, it should say divisor. I've changed our handouts here a little bit, so you might want to correct this one. If it says division, it should be the divisor is x plus 3. The leading coefficient, of course, is 1, and that's the only way we can do synthetic division. If we're dividing by a binomial to the first degree, and it can't have a leading coefficient, it has to have a 1 for that leading coefficient there. So it's a little restricted, and I do have the steps written down for you if you have any want to review those. But basically, synthetic division, we still have to write everything in its order. We can't leave out any terms, and we can only have those restrictions that we said on the divisor. So I've got this written out. All I need is the coefficients of these terms. And I'm going to write them in an upside down on L. And to keep from confusing it with the division house, I'm going to say the coefficient of x cubed is 1. The next term, the coefficient is a negative 4. The next one, it's a positive 2. And the next one, it's a negative 3. And I usually write all the signs in because it keeps me from getting confused later. What am I going to divide it by? Well, this is trying to find something called the zeros of the function. So really what we're saying is we're going to divide it by the opposite of that constant term. So the constant term here is a 2. We'll divide it by the opposite of that, or a negative 2. The first step is to just bring down the first number. And now I do multiplication. I say negative 2 times 1. And I write it under the second number. And now I'm not going to subtract. I'm going to add these. I combine them. So I'm saying negative 4 plus negative 2, and it gets me a negative 6. Negative 2 then is multiplied times my negative 6 to give me the next term, which is a positive 12. I combine 2 and 12 and get a positive 14. And then I keep going until I'm finished. I say negative 2 times this positive 14 is going to give me a negative 28. And when I combine that with negative 3, I end up with a negative 31. Remember, I'm adding these. In division, in long division, we were subtracting, but this time we've kind of taken care of the subtraction because we've changed that sign, haven't we? Now, what we do here is we start with one less than the degree of the polynomial that we were dividing into. This was x cubed. This is going to start with x squared. So it's 1x squared, and we work our way down, minus 6x plus 14. There's my constant term. So this one is my remainder, and I'll write it like this, plus negative 31 over whatever my divisor was, x plus 2. You could, of course, said minus 31 over x plus 2 if you wanted to eliminate one of those signs. All right, let's do it again. Check to see, do we have every term included in both of these polynomials? And it looks like we do. So all I have to do now is write down my numbers. I'm going to say 5, my coefficients, a positive 3, negative 7, negative 1, and negative 11. And I'm going to be dividing by the opposite of my divisor. The opposite of that constant is going to be a negative 2. First number I just bring down, and then I multiply negative 2 times 5, and I get negative 10. I'm going to combine these two numbers, and I come up with negative 7. Multiply negative 2 times negative 7, I'm going to come up, this time it's positive 14. Well, I'll just add these two together, and that's like 14 minus 7, which is going to be a positive 7. When I multiply this positive 7 times a negative 2, I'll end up with a negative 14. When I combine that with a negative 1, I have negative 15. Multiply negative 15 times negative 2, I'm going to get a positive 30. And this would be like saying 30 minus 11, which is going to give me a positive 19. Now I'm going to start with one less than my exponent here in my first term. So I have 5x cubed, and work my way down, minus 7x squared plus 7x minus 15. I've got the constant term. So this one, the last term, has to be my remainder, and I'll write it over the divisor, which was x plus 2. Third example, let's write this one the right way. This has to start off with the highest degree term, so it's got to be x to the 4th. I don't have an x cubed, so I'm going to have to insert one. So I have a 0x cubed. I have the x squared term, and I have the x term, and I have the constant term. And it's going to be divided by x minus 5. That one was fine. Let's write the synthetic division coefficients. The first one is 1, and then I have a 0, and then I have a 3, a negative 10, a positive 16, and I'll put it in my upside down division house and say I'm going to divide by the opposite of whatever this constant is in the divisor. And since it's minus 5, it will be dividing by a positive 5. I'll bring down the first term and multiply 5 times 1. I have a 5. When I say 0 plus 5, I just get 5. Multiply 5 times 5, and I have 25. Combine 25 and 3, I get 28. And then I say 5 times 28. This is where you usually reach for your calculator, and you get positive 140. So really, we just subtract 10 from that, and we'll have a positive 130, won't we? And I'll multiply 130 times 5, and I'm going to get 650. When I add 16 to that, I'm going to have 666. So it was an x to the 4th that I began with. I'll end with 1x cubed plus 5x squared plus 28x plus 130, that's my constant term, so this one is a remainder, plus 666 over my divisor, which was x minus 5. Now let's take what we've just practiced in long division, in synthetic division especially, and see if we can use it to solve problems using the factor theorem and given zeros. Now zeros, if you remember, are where we have answers really to our graph, and zeros, if you want to make a note to yourself, I've added some to this page. So this is really inserted above the problem set that you see on your page. Zeros are the same as the x-intercepts on our functions. They're the same as the roots of the function. I'll put it over here, roots. And they would just be called all of that. I mean, they could be called zeros, they could be called the x-intercepts, they could be called the roots, and you'll see it listed that way in My Open Math, and you just remember all of these are the same thing, okay? Zeros, x-intercepts, and roots. Now, what it is it's when we actually can find the zeros, when we factor out, and we had factors that would, we could make those factors, set those factors equal to 0. Remember, we could find the x-intercepts of the graph. We could find the zeros of the graph. Well, when we have a problem that's very, very difficult to factor, and we can't factor it a normal way, we can use, or can't factor it using intermediate algebra skills that we've already learned. We can sometimes use this and the factor theorem and maybe a given 0 to help us out. And that's what this problem is going to illustrate for us here. So what we have is x cubed minus 49x plus 120, and it's set equal to 0. And it says solve this, assuming that 5 is one of the zeros of this function or this equation, okay? Now, so what we have to do is figure out, well, we're going to have to go ahead and do some division. And we're going to say, okay, I've got x cubed, don't I? And I've got a positive, and then I'll have plus 0x squared minus 49x plus 120. And it's saying if 5 is a 0, this thing has been divided by, it's been divided by x minus something or x plus something with 5 in it, right? And I got a remainder of 0. Well, what was it? Was it x plus 5 or x minus 5? Well, if 5 is a 0, then what that means is we ended up with something that said x is equal to 5. And to do that, if I back it up here, I would say, well, what would that be if it was 0 equal to, well, I'd subtract x minus 5 would be equal to 0, right? And so I know that I'm working with the factor x minus 5. So I can take this and use this that I know and say, okay, now let's divide this out and see what the rest of it, the other factor is. I mean, I know that this is going to divide evenly into it because it's given to me as one of the zeros. So let's take and do synthetic division with it. And I say, well, this is a coefficient of 1, and then I'll put plus 0 down, and I'll say minus 49 and plus 120. And this first division problem is going to just kind of prove to me that that 5 is a 0, but it's also going to give me the factor that is multiplied times x minus 5, okay, to get this polynomial. So I bring down my 1 first, and I say 5 times 1 is 5. Add those together, and I'm going to come up with a positive 5. 5 times 5 here is going to give me a positive 25. When I combine those, or add them if you want to think about it that way, I get a negative 24. And I say negative 24 times 5 is going to give me negative 120. And when I subtract those, I get a remainder of 0, which is what it told me. So what is this polynomial? Well, 1 less than x cubed is x squared plus 5x minus 24. So what do I know? Well, I know that that polynomial times the other factor that I figured out, because it told me 5 was a 0, was x minus 5. And I know that's going to be equal to 0, right? So if this is a 0, and what else could be a 0? Well, now I have a simple trinomial just to the second degree, and I can probably factor that. Let's try it anyway. I have x minus 5 over here, and I'm looking at this one to see if it will factor. And I'll have two factors, hopefully, that I can set equal to 0. So what do I have first here? Well, I'm looking at it, and it's going to be, this should be 24, sorry. I'm looking at it and saying it's going to be x plus a number and x minus a number. Factors of 24 that subtract to give me 5. Looks like it's going to be a positive 8 and a negative 3. And I would FOIL it very quickly to check. X times x is x squared. 8 times negative 3 is negative 24. This gives me 8x minus 3x, which is 5x. So I have my three factors set equal to 0, and each of them will give me my zeros, my x-intercepts, or my roots, however you want to think about it. So the first one I set to 0 is x minus 5. And then I say x plus 8. And then I say x minus 3. So when I solve these, I'll add 5 to both sides and find that x could be a 5. I'll subtract 8 here and find that x could be a negative 8, and I'll add 3 here and find that x could be a 3. So the solution set, the zeros of this particular function, because we're going to look at it as a function later, is going to be, and I'll write them in ascending order, negative 8, positive 3, and 5. And I'll write it in set notation. X is equal to those three numbers, and that would cause me to find the zeros, or if I was graphing it, those would be the x-intercepts, wouldn't they? We could also call them the roots of the function. Now we're going to use another one. This problem is a little more complicated, which is why I put an easier problem in before it. This one has given us two zeros, two roots, if you will, of this particular function, and we're going to use synthetic division to determine the remaining roots. So this is going to be a little bit more complicated because we've been given two roots this time. We're going to have to work with them one at a time. So let's start out with our function here and see if we can divide it. We're going to say it is 72. It's the first number here. And then the second one, and it is, I checked, all the terms are in descending order, and I'm not missing any terms. So I've got a positive 72. I've got a negative 150, I've got a negative 210, a positive 30, and a positive 18. Now that's all going to be divided by one of my roots. I was told that negative 1 was one of the zeros. Now that would mean that the factor was going to be, the factor I'm going to be working with would be x plus 1. When I divide, I would use the opposite of that constant, which would be the negative 1. Remember, when I have the 0 is x is minus 1, the factor is going to be x plus 1, because to get a negative 1 to be my 0, I would have to, for this to be equal to 0, x would have to be negative 1. When I have this as a factor, of course, I will use the opposite of it to divide into my polynomial. I'm going to bring down the first number. It's a 72. Multiply, and I get negative 72. And when I add these two together, I'm going to get negative 222. Multiply again, and I'll get a positive 222. And subtract those, and I'm going to get a positive 12, right? Negative 1 times that's going to give me negative 12. When I subtract, I should have a positive 18. And then I will multiply times negative 1. I'll get a negative 18, and there, I did have a remainder of 0, didn't I? So did I prove that negative 1 was one of the true zeros, or one of the roots of the problem? I did. And now I can say, okay, if negative 1, one of these factors, and I know the factor is x plus 1, right? The opposite of the negative 1. Then let's check the other one, which is a positive 1/3, isn't it? That would make a factor of x minus 1/3. But let's go ahead and divide it into our remaining polynomial. There's no sense in dividing this one. We want to get this broken down as much as we can. We have one of our factors. Let's divide this one again. Well, let's figure out what it is. It's 72x to the power of what? We started off with x to the 4th here. So this one will be x cubed minus 222x squared plus 12x plus a constant of 18. And now I'm going to take that and do another division. I'm going to say I want this one to be 72 minus 222 plus 12 plus 18. And I'm going to divide this one by what? Well, it told me that 1/3 was a factor, didn't it? Was a 0. So I know that this factor would be x minus 1/3. And I would take the positive 1/3 that they told me, and that's what I would divide by. All right, this is the same, dividing by a fraction, I mean, multiply it. We're going to be multiplying. When I multiply by a fraction, it's like dividing by that denominator as long as I have a numerator of 1, right? So I say 72, I'm just going to bring it down. And then I say 72 times 1/3. Well, that's really 72 divided by 3, isn't it? So the math's not as bad as it looks. 72 divided by 3 is a positive 24. And I combine these two, I end up with a negative 198, which I divide by 3 and get a negative 66. And I combine these two and end up with a negative 54, which I divide by 3 and get negative 18. And I do find out that, yes, 1/3 is one of my other zeros. And it did work dividing it into the remainder of the resultant polynomial that came up from my first division. So I'm just continuing breaking it down. Now let's see what I've got here. I've got 72x to the power. Well, I started with x cubed here, didn't I, when I created this one? So this is now 72x squared minus 198x minus 54. And now it looks like this could be a polynomial that I could actually factor, because I've factored trinomials to the second degree before. So I'm going to put my factors all in place. I know I have to have this one times this one times this one. I'm just going to write them down. I have x plus 1, was the first factor I found, times x minus 1/3, times 72x squared minus 198x minus 54. And all of these will be equal to 0, because that's what I've set it equal to, so that I can determine what the zeros are. All right, this one is a little bit confusing. The math's not as nice as we would like it to be. You would see that these three numbers all divide by 9. And then if you kept going, you'd see that they also divided by 2. So they're all three going to divide by 18 evenly. And that was a little bit of work to get there, but you know how to do that. So I've got x plus 1 times x minus 1/3, and then I'm going to pull that GCF out, and the GCF is 18. So when I divided each of these by 18, I ended up with 4x squared minus 11x minus 3. And that's all equal to 0. Now this is another polynomial that I've still got to factor. And I really don't want to go to the quadratic equation. I'm going to come over here and use my old factoring system. I'm going to use my diamond method. I'm going to write 4 times negative 3, the a times the c term, and then I'm going to write the coefficient of the b term here. And I'm going to create my factors here with this coefficient and the variable, the square root of x squared on top. And I know, because this is a minus, that I have to have one factor that's positive and one factor that's negative. So underneath here, if I just put those factor pairs down, I would see that it looks like x plus something, x minus something, and I hope I can come up with factors of negative 12 that when combined, subtracted, will give me a negative 11. And I'm looking at it and saying, well, it's probably going to be 12 and 1, isn't it? I need the result to be negative, so the bigger number has to be negative. And I can say the first factor is 4x plus 1. The second factor can reduce. That's why we write these as a fraction, so we can see that both of these will divide by 12, and this becomes, by 4. This becomes 1x minus 3, or just x minus 3. I'm going to FOIL to check. 4x times x is 4x squared. 1 times negative 3 is negative 3. Inside is 1x. Minus 12x would give me my minus 11x. So let's finish writing down all these other factors here. Now, typically, this coefficient that's not multiplied times anything would be written out front. But you can see that each of these is a factor. And if any of them was 0, then we would have a true statement. So we're going to go about setting each of them equal to 0 and solving. X plus 1 equals 0. X minus 1/3 equals 0. 18 will never equal 0, so I don't even have to use that one, do I? 4x plus 1 equals 0, and x minus 3 equals 0. Let me solve each of these. I'll find that x could be a negative 1. X could be a positive 1/3. 4x could be equal to a negative 1, and then I have to divide and say x could be a negative 1/4. And x could be a positive 3. So what is my solution set? There they are. X, to find the zeros of this polynomial, would be, and I'll start from the smallest one. Negative 1 looks like it's the smallest one. Doesn't really matter. I don't think my open math cares. And I've got a negative 1/4 as the next one. I've got a positive 1/3. And I've got a positive 3. And I've used synthetic division to find the zeros or the x-intercepts or the roots of what is going to be a function, which will help us to graph it later on.